Next algorithm is problems on this round robin scheduling. So in the round robin is very popular among the sports and games activities. Okay, it is actually each time slots will be given, and in that given time slice, okay, this will the round and scheduling similar to the first come first serve scheduling only. Only difference is that time slice based preemption is added. Okay, to switch the execution between the processes in the ready queue state. So you can see here four processes are running. Okay, each process will be given some limit time slices. Okay, whether how much time it is completion time, execution time is irrespective of that. Okay, time slices will be given after that time's duration. Immediately, resource will be given to next processes. Again, after the completion of the time slices, next processes will be given to the next process. Again, after this, so this will complete once process is complete, that will be eliminated, and remaining three time slices will be shared. So like that, this will be continuing till all the processes are completed in that slime slots. So important problem in this one is exam. So many times it is asked. Go to the problem now. A very important problem. Okay, it is important and it is based on round robin. RR algorithm means round robin algorithm. So three processors with IDs P1, P2, P3 with estimated completion of 642 milliseconds respectively enters the ready queue together in the order P1, P2, P3. Calculate waiting time and turnaround time, and average waiting time and average turnaround time, assuming RR algorithm, that is round robin algorithm. And in this time slice is 2 milliseconds. So note down the time slice. It is P1 is 6 millisecond, P2 4, P3 2 millisecond. Time slice is 2 millisecond. Okay, so don't write all these stories, you can start from here only. So all appear together P1, P2, P3. P1 is 6. Okay, and they appeared in P1, P2, P3 only. So first scheduler will schedule to P1. So it is given 2 milliseconds. So first divide each time slash as 2 milliseconds. It is fixed 2 milliseconds. You have to fix. So time axis is 0 seconds, 2 milliseconds, 4 milliseconds, 6 milliseconds, 8, 10, 12. Like that, you have to keep on divided by 2, divided by 2. Each time is 2, 2, 2, 2, 2, 2. And each process should be given 2 milliseconds. So first P1 no. So P1 total how much is 6 millisecond is there. Total job is 6 millisecond. In the first slime slice it is given 2 millisecond job is over. 2 milliseconds job is over. Till how much is left? P1 actually P1 2-minute job is over. So 2 is over. Still pending is there. Next P2 will be starting. Next P2 will start. So P2 will start. Its job is 2 millisecond. Again, next P3 will start. So P3 see how much? First slime slot P1 2 millisecond job is over, 4 is remaining. In the P2 out of 4 millisecond, 2 millisecond job is done. Still 2 millisecond is pending. But in P3 job is 2 millisecond, and in that time slot it overs. So no plus for this. It completes. 2 and end. It ends here. Okay. Now no more waiting for this. Once it gets its 2 minutes start, it is completed its job. Next, after that, out of these three, once again P1 will get its chance. In the round robin circle is there now. Once again it will get its chance. So out of that, again it will complete 2 milliseconds job. Still 2 millisecond job is there. So again next after that, next time slash should be given to the next P2. P2 will complete its, and see P4. P2 is 4 millisecond, and in the 4 millisecond it's complete its job. So it ends here. Again next P2 and it ends here because this is 6 millisecond now. Suppose 7 millisecond is there, means again P1 only once again with 1 millisecond job it is going to do. 8, suppose it is 8. Again once again P1 only get its turn because no other steps are there. Now calculating waiting time and turnaround time is very very tricky in the round robin. So please check properly what is the waiting time for P1 for a very first time. Out of these three, if P1 is completes here, P1 is completing here. Wherever P1 is there here, that is running. Wherever P1 is there, that is running. Wherever it is not there, it is waiting. So for P1, it is waiting this much. See, P1 is getting here, starting 0 waiting, and here to here it is waiting, and again here it is waiting. So it waited 1 slot, second slot, 3 slots. So waiting is 2 millisecond, 2 millisecond, 2 milliseconds. So totally 6 millisecond it is waiting. Okay, directly you can see the diagram and you can write too much 2 millisecond waiting, 2 millisecond waiting, P2 here 2 millisecond it is waiting. Three time slices it is waiting. Next, what is the time slice waiting time for P2? Here P2 is here, P2 is here. So up to here only you have to consider. Okay, here it is waiting, here it is waiting, here it is waiting, here it is running. P2 is running, P2 running and completes here. So it waited here, it waited here, it waited here. So waiting time is 2 millisecond plus 2 millisecond plus 2 millisecond. Again it is waited 3 slices. So it is 6 milliseconds. 6 millisecond is the waiting time for P2. What is the waiting time for P3? PT only 2 minutes job, it ends here only. It ends here only. But it waited 1 slice and 2 slice. So it is 4 milliseconds. And calculate average waiting time. Add of 6 millisecond of P1 waiting time, 6 millisecond of P2, P3 waiting time is 4. So add these 3 divided by 3. That is the 5.33 is the average waiting time in round robin algorithm. Next, turnaround time. Turnaround time for P1 is waiting time plus execution time. Waiting time is how much it waited? 6. P1 running, waiting, here waiting, P1 running, P2 waiting, here run and completes. So it waited 6 milliseconds, that is 3 slots, 6 milliseconds plus execution time is 6. So 6 plus 6 is 12 millisecond is the 12, 12 millisecond is the turnaround time. Similarly, turnaround time for P2 is waiting time is 6. Okay, waiting time is 6 plus execution time is 4. 6 plus 4 is 10 millisecond. Now turnaround time for P3 is waiting time is 4. Waiting time is 4 plus execution time is 2. 4 plus 2 is 6. And average turnaround time is 12 plus 10 plus 6 by 3, which is 9.33 millisecond. You can stop here only. There is another method to calculate the average turnaround time. Anyway, we calculated here now, so no need to study this. This is optional. No need, because we already, this is another way to find out. In all the other problems also you can do this, but if you understand first method only, don't go for this. Okay, the same answer you are going to get, but with a different method. Thank you.